know I was going to get my own theme music for coming up on stage. So I hope everybody had a good break, got to meet and talk to some people, enjoyed the morning talks. I ate a pear. It was fantastic. The strawberries were huge. People were commenting on how big the strawberries are. So welcome to the United States, where strawberries are huge, apparently. I'd like to welcome our next speaker, Lars Wikman. Lars is from Sweden. My horrible Swedish accent. He has his blog is underjord.io, and if you're American, it's underjord. Lars runs he puts up the Nerves newsletter every week, month. I read it. 2 weeks? Okay, that's why it felt like a month. It always feels too long whenever I don't get something from him. So, Lars, welcome.
Thank you. Thank you so much for having me. And I like to start off with doing something other than an introduction of myself. So we will start with a demo. And grab this one. So I am, dear assistant, I'm speaking at Codebeam America. What do you want to tell these people?
It is a pleasure to meet you. I am Emily, a talented florist with a passion for flowers. I have been working with some of the most exquisite and delicate blooms in the world for years. I hope you find my arrangements beautiful and meaningful. I am Emily, delighted to have you in my studio. I must say I am quite impressed with your work. It is truly remarkable how one flower can bring such joy to other.
I'll cut that one off there. So, the power of AI, revolutionary, that's what I hear. That's the demo, that's as good as it gets, that's the full package. But the point of the talk is kind of to explain what's going on there and what we're doing. So to give you just the nutritional contents, contains machine learning, membrane media framework, a little bit of LiveView, but not really. We use LiveView, but it's not the topic. And I'll try to get into sort of the crunchy bits of how we actually sling media around and all of that stuff, and that involves a lot of the membrane framework. All right, introduction. Lars Wikman, that's me. I do a ton of things, and I'm just going to call out the ones that I think people have missed, because as you see, there's a bunch of stuff on there. Who here has heard of Goatmeyer Elixir? Yes, that's pretty good. That's an Elixir conference I'm putting on in Sweden in September. Please come if you can make it. Who knew that there will be in a NervesConf EU? Much fewer. Same place, same date. It's all connected. You can go to Sweden and do both. Who knew you could buy Elixir shirts now? Cool, also Nerves shirts. This is the first public showing of the official Elixir shirt, done with the blessing of the core team, sold at oswag.org. And that's about as much of a sales pitch I'm gonna do. But I want people to know about it because I think it's nice that we can get shirts now. Professionally, I do nerves mostly. I do Elixir consulting in general with a small team, but I do a lot of nerves, and I focus on security. I'm also part of running Nerves Cloud, which is hosted, managed Nerves Hub. So I do a bunch of stuff with firmware updates as well. I'm also on the Nerves core team now. I'm mostly the mouthpiece, but I also actually do some code. But like Frank and John prefer to push me to the front every now and then, and that suits me fine. This is not a Nerves talk. I found that I stepped in sort of late, and Per is giving an IoT talk in the next room. I thought that would be rude. So if you want a Nerves talk, go to Digits Talk tomorrow. Nerves and Flutter, it's gonna be great. Okay, to the topic of running machine learning models. This is not an actual quote. No one said this except me, maybe yesterday. But has anyone else felt that suddenly your machine is sort of limited in what it can do? It could just be me, because I keep trying to run local machine learning models, which I guess is a bad idea. But also I work with embedded hardware, so I run into limitations all the time. But we can take a look at what we're working with. This is my MacBook Air, 24 gigs of RAM. Any given day, it tends to indicate that it has about 11 gigs to spare. It has a nice GPU. It has Apple's Neural Engine. It has a surprisingly capable CPU. It has no fan, no active cooling. It's way stronger than embedded devices that I work with. It's way weaker than my Linux workstation, and it is nothing compared to the typical GPU server. So for this talk, I run everything locally. That's why the LLM is a terrible florist named Emily for some reason. It's not a very good LLM, but it does fit into 11 gigs of memory. All the models I will be using will be open-ish, open weights, usable licenses, that kind of thing. And currently, of course, the best LLMs and LLM services are the proprietary ones. But if you can crunch down a llama model, that would also do a better job than the one I'm using. And why do I not just use like a cloud-hosted one, like OpenAI or Anthropic or something? It's like, do you also run your workloads on like AWS or Google? It doesn't seem like much sport. Come on. Do you put files on S3? I don't know why you would do that. FTP servers are fine, right? Now, I find the challenge interesting, and there's also the privacy and all that. In AI, people talk about a mixture of experts. That's not what we have here. I have very simple, stupid models that come together and do something decent. And we will go through those models. So this is our LLM. Or large is questionable. It's a chat model called Small LM. It's the 135 million version, and it's an instruct tuned one. So it's a small LLM. Whether that's an SLM, an MLM, or just a plain LM is unclear to me. I don't know where the sort of boundary is for large anymore. Humongous language model, is that a thing? But I think this one could fit on a Raspberry Pi if you buy one with enough RAM. I don't think I have an 8 gig Pi, but I bet it would fit. So if you do have an 8 gig Pi, try it and let me know how it works for you. I also run Whisper, which is a speech-to-text model that I've used in presentations before. It is a nice sort of workhorse model. In some ways, this talk is a bit of a sequel to a talk I gave at ElixirConf EU, where I was controlling my slides with my voice and stuff using Whisper. But this time, we're getting more into how things work. Whisper runs well on CPU. In my Nerves talk in Berlin last year, I had it running on Nerves devices down to at least Raspberry Pi 4, and I think you could get it on the 3 as well. It would just be slow. One member of the community, Samrat Mansingh, made a library that supports this model, Kokoro, and I've been looking for a convenient text-to-speech model. This one is very reasonable. It has a bunch of options for voices. It's capable. It runs well on CPU. I've had no problems with it. It's not fantastic. It's not like the top of the line. Again, then you'd be using data center GPUs and stuff. Celero VAD. This one is kind of key to what I'm trying to do because it's very useful for voice. It answers one single question. Is this chunk of binary data voice or not? So it's a fairly simple model. I think I found it through a Sean Moriarty post on doing a voice assistant with NX. And it's been very interesting to noodle around with. I have run it successfully on Nerves devices. And yeah, it runs really light. You can run it on CPU, no problem. So that's the crew. 4 different machine learning models in one talk, various heaviness. And I think it's important to realize that all of these models do useful things, and it's not just the LLM show. The non-LLM ones are easier to use, easier to work with. and do things more dependably, generally. So they are very good building blocks for making the LLM do something well. The VAD, for example, means that we don't have to get Whisper involved until there is a high likelihood of someone actually using their voice and speaking. And I've used Whisper without. You get a lot of parentheses, silence, or ... or clatter, or noise. Or it starts making stuff up. I have actually had to add a manual filter for the words yes and thank you, which it will invent out of any type of noise that it receives, because it wants to be polite and responsive, I suppose. So the way I run these models, I use NX. I use a few different techniques, but because who I am as a person and I want to do everything with Elixir if I can, I'm a bit of an extremist in that regard, I prefer the NX-based ML models, and they slot into supervision super nicely, and they can do a bunch of cool clustering type stuff that I don't do in this talk, but in general, they're very capable in that way. It also means I get fewer dependencies and that. So I run both Small LLM 2 and Whisper using Bumblebee and NX and Axon. I'm actually utilizing the new support for Apple hardware, so eMLX instead of EXLA if you've played around with NX. It works well. Things are a lot faster on this GPU than running them with EXLA on the CPU. It has some limitations. It's not published on Hex yet, but you can run it from GitHub. Then we have two models that I run using Ortex and ONNX, and that's the smaller models. Ortex binds using Rustler to a Rust library called Ort, which is binding to the ONNX runtime, and ONNX is a format for portable machine learning models. It's not the most efficient way of dealing with machine learning models, but it's portable, which means it's like 1 or 2 files, and then you have your model where you need it. There are ways of running ONNX in accelerated fashion using various execution providers. Not doing any of that. I'm just running them on the CPU. There are also limitations to using Elixir's machine learning support. And I think that's one of the reasons why we recently saw PythonX announced. But yeah, if you look at, for example, llama.cpp, which is a non-Elixir project, they have their own format for models called GGUF, which lets you run heavily quantized, big machine learning models in less RAM, or less video memory, as it may be. They lose a bunch of precision, but it allows you to adapt the model to the hardware you have. And we don't really have that yet. Axon has basic quantization, as it's called, and I'm sure we'll get more of it over time. But there are limitations to doing Elixir and ML for now. On my flight here, I was working on the outline of this talk. And if the talk seems a little bit unwieldy, I will blame the fact that I could not get those 12 hours of focus time that I had planned on the flight. I got pulled in to give the talk because someone dropped out. I was just going to attend, but it's a fun time to give a talk, so I'm happy to step in. But that meant I had about a week to put together a talk, so I was going to use those 12 hours, was my plan. But next to me on the flight was a very drunk, very social, ex-special forces Norwegian man. He was reading my outline as I was typing it and felt absolutely compelled to discuss it with me. And when he realized I was Swedish and I was talking about something to do with streaming audio, he was like, "Do you know about Nyquist?" I'm like, "Yeah, I've heard the name." "You're Swedish? You're going to talk at a conference about audio and you don't know about Nyquist?" He was very upset. So he wanted me to be able to relate the Nyquist-Shannon theorem. He didn't know the theorem either, so I had to look it up after. But as a Swede, I was apparently, was apparently necessary for me to know this. So the Nyquist theorem says that to record something digitally, you need to sample it at more than twice the rate of the maximum frequency of the signal. So we often sample music at 44,100 hertz, and the exact number has some historical and some technical reasons. I mean, Sony and Panasonic had to agree on things, for one thing. But fundamentally, it means we are representing any signal from 20,000 hertz and down pretty accurately. And 20,000 hertz covers most of what we can hear, so it's good for music. And while most of the human voice will stay within 8,000 hertz or so, so we typically sample voice at 16,000 hertz. So that's very common when we're dealing with voice processing. In this system, I'm using 16,000 hertz and 24,000 hertz, depending on the model. And I think I have now satisfied the overly social Norwegian man I spent 12 hours strapped in next to. He kept ordering wine. All right, so the things we're doing in no particular order, well, actually the exact order. The initial input is a microphone input from port audio. It produces audio. Then we have a peak meter, which measures the amplitude of the signal. And that just takes the audio in and passes it on. And then we have the VAD, so the voice activity detection, which takes audio in and then actually just passes on the parts that are voice. Another peak meter, because I wanted to know what the waveform looked like after. Then we have Whisper, which transcribes the audio, so it turns audio into text. And then we have text, and that goes into the small LLM, which adds the transcript to like a messaging exchange. And then, so that's a text in and then text out stream. And then we have Kokoro, which generates speech from the LLM's output. So we get text in, and then we produce audio out, and then we resample that, thanks to Shannon and Nyquist. And so we adjust the sample rate. I said bit rate there, which is not quite right. And the final destination is just the audio output so that you can hear it. That was the initial demo. So who here has tried Membrane? A couple, but it's always a fairly low number because Membrane is kind of odd. Not everyone has even heard of it. It's a media framework for Elixir if you haven't heard of it. I personally really like it. I'm a bit of a sucker for production gear and audio and video stuff. It's built by Software Mansion, a Polish consultancy who keep doing a bunch of cool stuff. Like we have WebRTC, libraries for Elixir. That's a heck of a lot of work. And they do video composition and a lot more. So they specialized in this area. Membrane wraps up common tools like FFmpeg, import audio, and friends into Elixir abstractions that operate under supervision trees in the sort of regular expected way. So you build a pipeline of elements, and I would say that it's a DAG, so a directed acyclic graph, but you can have cycles, so it's not. This is a warning that I think need to be put on anything that deals with media. It's like, yes, the Membrane framework is easy. It makes media simpler because media is just fundamentally a pain in the neck. It's a little bit rough. Audio, but especially video, are just more complicated than anyone would like them to be. The big reason is it's a lot of data that needs to be transferred over a small, small pipe, and then you do weird things to it to make that work. And also a lot of weird large entities need to agree on what the encodings, decodings, and containers are, which makes everything worse. So you're dealing with encodings, decodings, containers, bit rates, color spaces. You never see just a series of images, which is what you expect video to be. That's MJPEG. That's the only one that works that way, which is just several JPEGs in a series. Audio is not that bad once you have it decoded. Raw audio is manageable. You have some channels, it's usually 1 or 2. You have formats, so it could be signed, unsigned, floating point. You have a bit depth, 8, 16, 32 is kind of typical. You have the sample rates. Again, Nyquist, Shannon, pay attention. Or the Norwegian will come for you, I suppose. So raw audio, when you have it in a raw format and you know what shape it is in, you can actually immediately calculate where you are in the stream or what the duration is based on the bytes. You can't do that with an MP3 because it's variable. But if you're dealing with an MP3, libmad will turn it into raw audio data, and lame will turn raw audio into MP3, which is helpful. Membrane can actually pipeline any data. It is not necessarily a media pipeline. I pass a bunch of text, as mentioned. So I made a format just so Membrane can shout at me if I do it poorly. Excuse me. All right. I think that's enough background, so let's see if we can do sort of look at the evolution of the pipeline. The very kind AV gang here helped me set up, and I'm just doing them a lot of disservice today because I'm playing audio. Where did my mouse pointer go? I would love to, if I still had a mouse pointer. There? Okay. Okay, now we have a mouse pointer. That'll help. So the absolute first, simplest is this one. And I have to be a little bit careful. I should not put this in front of the speaker because it will feed back. This is a port audio source and a port audio sink. It will literally just echo. This is the echo server of audio, which you should be very careful with because it gets loud if you do it wrong. And this is the absolute most basic. Like, I'm getting audio, I'm putting it into Whisper, I'm showing the transcript, but I'm not even doing anything with it. So you can see the little transcript. I hope you can see it. It's popping up there in the corner. And it's just doing like single words, which is kind of terrible. It's just doing whatever audio chunks the mic input is feeding it. And you can also do it with the amplitude meter, and then I have LiveView render it as this kind of weird waveform. But we can actually add, so now we add the VAD. And the green indicator around the screen is when I'm speaking continuously, and if I speak continuously, it will actually just keep glowing, and nothing gets transcribed until I stop. Thank you, thank you. So this is incredibly helpful for making Whisper do a better job. You're giving it a lot better of an input to work with. And then we have this one. This is actually the funniest demo to me. This is kind of taking the Google Translate to one language and then translate back and see what you get, but with audio and text.
We have this one. This is actually the funniest demo to me. This is kind of taking the Google Translate to one language and then translate back and see what you get, but with audio and text.
Let's try some words it usually struggles with. So Underjord is an Elixir consultancy that focuses on nerves and security.
Let's try some words that usually struggles with. So under the word is an Elixir consultancy that focuses on nerve and security.
I mean, fair enough. It usually goes with Alexa instead of Elixir. Yeah. Poor things interrupted. So this is the other approach. If we let it speak and we skip the VAD, this is what we get.
The other approach, if we let it speak and we skip the video, aid, this is what we get. The other, thank you, approach, thank you. Let it speak, Harry, thank you. We skipped the video, thank you.
Yeah, okay, so I think this is just the rest of the talk. We just see what it does.
We'll go, thank you. Thank you. I'm not gonna rush. So.
Did I mention it tends to sort of err on the side of thank you? I'm very sorry, but I'm not Harry also. So the pipeline I built, we can go through that a little bit, what it does. So I specify a bunch of children, which make up the pipeline's contents. But the pipeline is a gen server that can receive notifications from its children, which is not the audio signal, but it's anything that you want to pass in a side channel. So for example, the amplitude messages come in through notifications. The amplitude part doesn't change the audio, it just tells you about the audio as it's measuring it. So this pipeline gets to aggregate the event, so I don't spam my LiveView with more updates than 60 FPS, for example, which would be kind of pointless and also bad. So it broadcasts using Phoenix PubSub whenever I feel like it, at whatever rate I feel like. It runs under a dynamic supervisor, so when I was switching, I was killing the pipeline and starting it up again. I keep the models running on the side, or the heavier models, I keep running on the side separately, because they have a little bit of startup time. So every child in a membrane pipeline is an element, and we call an element a source if it produces outputs. We call it a sink if it only takes inputs, and we call it a filter if it takes inputs and produces outputs. There can be multiple inputs and outputs. Multiple inputs and a single output is pretty common when creating a video from a video stream and a separate audio stream, for example. And then we have T-junctions, which is like, oh, maybe we have this MP4 stream and we want to live stream it and put it on some S3 bucket somewhere, but we also want to just store it contiguously to a file for later. Then you can use a T-junction. But there's a ton of different things you might want to do in terms of splitting streams. So you take these elements, you connect them up. You tend to start on a source and end on a sink. Otherwise, it doesn't really work. And I'm using some of the membrane sort of standard plugins or membrane project plugins. So port audio is very important to what I'm doing. If you're doing a web service, you probably wouldn't use port audio. You would use some WebRTC stuff or just open the microphone and pass audio over channels. But fundamentally, you need to, if you want to open a microphone, you need a mechanism for doing that. This one does it on the local machine, which is not great in the cloud, but works super for this. It also does output. So if you're working with a bunch of media devices, it might be very helpful as well. File plugin. I mostly use this during development, but I could feed a podcast episode straight into the thing and see what it did, for example. And when I was debugging, like, oh, is this a problem with the text-to-speech model, or is it a problem with the data I'm sending? Then writing it to a file and then listening to it was helpful. The fake plugin. For example, when I'm just doing the transcript, I'm not actually, I need something that consumes the stream, otherwise the stream doesn't go. So the fake sync, for example, will just consume but do nothing. The audiometer plugin, I use that a ton. It's very nice for a lively demo. It just passes out notifications about the amplitude of the audio. FFmpeg software resample. It changes audio formats. It's very useful, not that interesting. Custom plugins. So I wrote a plugin for each of these things, and the VAD is probably the most interesting one. I went through a few iterations on that. I had a version that would pass through silence, so it would keep, let's say, the distance between words, but it would just replace anything that wasn't speech with absolute quiet instead of having background noise, for example. The current one will buffer within a tolerance for a number of chunks, and like as long as you keep talking, it will essentially build up that buffer, and then there's a limit because the downstream elements don't want super long buffers. But you've seen I can do a pretty decent sentence and it will keep it all together. And I made that all configurable. So the element is pretty useful at this point. The Whisper one just takes audio samples, shoves them into Whisper, and produces text. And I also pass out text notifications to be able to send them to the UI out of band. Same thing with the small LM. It takes text, produces text, and it sends out notifications. And then Kokoro takes in text, produces audio. There's nothing particularly difficult about any of these. Some of them have tricky bits where it's like, how to talk. The VAD one, for example, the ONNX model, if you know the machine learning stuff, if you're good with tensors, it's easy. I'm no good with tensors. I don't do math. So figuring out exactly what you need to pass into it can be tricky. But there's nothing about membrane that makes the implementation tricky. And also I use LiveView. So I figured I'd touch on that. The most important thing when you're doing something like this with LiveView, the samples are usually fairly short, so there's a lot of them. So you need to be a little bit mindful about what you pass off to the UI. Everything visual I did, nothing of it was advanced. It was just HTML and CSS. I've done SVG with LiveView. That's a lot of fun, like doing graphs and stuff, or doing waveforms. We could have done the microphone and audio playback entirely with the browser, and that actually ports better to if you want to put it in the cloud or whatever. But fundamentally, like LiveView and Phoenix PubSub make this incredibly easy to make a UI from. That's the big takeaway of LiveView here. It's just doing its job as per usual. All right, and there's a bunch of code we could go through and discuss, and I figure we'll do this kind of open-ended. So are there any particular parts you're interested in or want to see? And we'll spelunk a little bit. This could also be considered the questions part, but I figure we should be looking at some code as well.
Hello. There we go. Can you make it bigger too?
Yeah.
Font. I'm old.
So this is a testing. There we go. This is a question, but maybe could lead to some code worth looking at. What I'm curious of is, you're using like smaller models, smaller memory footprints, and this sort of thing. And if you were to scale those things up, would any meaningful changes be required in your code? Like, would you have to sort of re-implement or redesign these things to handle, like, I don't know, make this a production AI assistant tool that sits next to you on your desk or something like that?
I think there's two different questions in that question, but they're both good, so we can go through both of them. Essentially, I could switch this to use one of the massive Llama 3 models, like the big ones, and it would just download a different model and run. And if we wanted to cluster it out and do all that, NX serving has us pretty well covered. There might be some adjustments. I think it's mostly config at that point, but not a lot that would need to change. And also, if you would like to do, for example, Flame, there is nothing stopping you from making a Flame call inside of a membrane element because it's just Elixir. So you could absolutely, like, I could make an element that's OpenAI API calls just as well. And they have streaming implementations and like WebSocket or WebRTC based stuff, so you can get really low latency. So it would be, in some cases, a different implementation and all that. One of the things, oh, interesting, an error. The trickier part, and something I realized doing all of this, is like there's stuff you want to do that Elixir really helps you do, but I didn't have time to really go into, which is like, if you have voice activity detection, you know when something's speaking. So I'm sending notifications that say start and stop for speaking. So I can actually indicate, okay, let's stop this this part of the process now. Stop feeding out audio. You're interrupting the assistant. You want to say something else. The assistant should just stop talking. That would be fairly easy to do. I had some time constraints. But making these models behave well together and making like a good interactive experience is a lot about figuring out like what is happening, providing the right information at the right time, being able to interrupt, being able to do things semi-real time. And I think we have very good capabilities in that regard. It's like, it keeps coming up. Like Elixir's pretty good at orchestrating things, and Membrane is very much about orchestrating a bunch of media processing. If you're dealing with Membrane, you will end up like installing dependencies like FFmpeg and a bunch of encoders, and then Membrane puppeteers those for you. And if you've ever had to figure out what to do with like the FFmpeg command line, Membrane is vastly preferable. So, but yeah, I can show the LLM. So I tried a few different LLMs. So there are a few LLM modules, but this is the one I use. So we defined a couple of options. So I can pass it a system prompt. I didn't, so I think we had an empty system prompt for this, which turned into Emily the Florist. I have not met Emily the Florist before. I've heard a few sort of recurring things, but not Emily the Florist. And then there's just the name of the serving. We define an input pad, it's raw text. We define an output pad, which is raw text. We do an init. It just sets up the options and loads a blank exchange. When it starts playing, we pass a stream format, which just says, this stream is raw text. Treat it as such. And we demand some input from the input side. So it's like, we want something, and this is how the pipeline stays lively. It's essentially, if you work with GenStage, it's very similar. You need to handle the stream format. This was something I ran into that's a bit of a gotcha, because Membrane has a default that makes elements behave as pass-through very easily, which tripped me up for a bit. When you get demand, you usually just pass the demand on unless you have something you want to do when you get demand. Then there's a handle buffer, which you get text. Then we take that text, we shove it into the exchange. This came from the user. We generate using that exchange, and we turn that into text. We save that as part of the dialogue, because we want to keep this exchange between the user and the assistant to make it make sense, so we keep that data structure intact. We produce a new buffer, we pass it on, and we also notify the parent, which is the pipeline, that the exchange is here now, so that we can show it in the UI. Yep.
I'm going to have to cut you off.
Yeah.
We are out of time. Jason, can you raise your hand? Jason had one question you put online that said, is this code available somewhere for us to look at?
I was going to put the GitHub link in there, but I never got to it. It is on my GitHub, github.com/lawik/relive, I think, or relive. I should rename it to Emily the Florist, probably, but yeah. That's it for me.
Thank you.
Thank you.
We'll be back in 5 minutes with Art.